In this tutorial, we will build a small, custom Abyss-style combat stage in Miliastra Wonderland. We will begin with one enemy wave and a simple victory condition. Then we will add a defeated enemy counter, a victory screen, multiple waves, a 2-minute countdown, a star rating, and settlement scoreboard data. By the end, the stage will have a complete playable loop. The player enters the arena. Enemy creations appear in waves. The interface displays combat progress and remaining time. Defeating every wave triggers victory. Running out of time triggers defeat. And the final star rating is shown on both the custom victory interface and the settlement screen. Before we start building, let us briefly explain the difference between classic mode and overdrive mode. Every time you try to create a new save in Miliastra Wonderland, you will be prompted to choose between classic mode and overdrive mode. Overdrive mode gives the creator much more control over player data and custom combat systems. Classic mode instead allows players to enter the stage with characters they already own in Tevat. Their character attributes, skills, talents, weapons, artifacts, and constellations are all retained. Therefore, classic mode is a natural choice for players to experience something they are familiar with in Tevat itself, with an emphasis on the character build of the players themselves. Spiral Abyss Remake is a very well-received topic of classic mode and of Miliastra Wonderland itself, with a lot of stages enjoying great popularity. However, they are really not hard to make, and we will show you how to make a simple Abyss-like gameplay in this tutorial. When we first enter the editor interface, we will be placed at the second page, Entity Placement. Just like in Genshin itself, we can use the W, A, S, and D keys to move around. By the way, you can press E or Q to move up and down, and if you want to change your viewing angle, just hold the right mouse button and move the mouse. The left part of the screen is the Assets bar. We would start at the Prefabricated tab, where we can find a lot of pre-made assets. Let's open Creation, then Basic Creation, find a Helitro, and place it in the scene. Is it complete at this time? Not really. All creations placed will have an initial level of 1. To make the combat of a proper difficulty, we need to adjust it. The right side of the screen is the details panel of this creation. Now we switch to Combat Settings, the second tab of it, expand Basic Battle Attributes, and set level to 90. Then we can start testing the stage. Click the top left menu icon, and the Assets bar will be hidden, with the system menu popping up instead. Then click the Quick Save button below, followed by the Test Play button in the first line, and we will be able to enter the stage as a player. When starting the game, we'll be prompted to choose characters, just like real players. After the loading process is complete, we can try to defeat the Hilicho we just placed. Currently, this stage won't end, because we haven't implemented any logic yet. Just press the Escape key and select Abandon Challenge to return to the editor. At this point, we have a very basic stage with one enemy. We will provide a phasic save file for you at every milestone like this, and you can find it with the Google Drive link in the description. Only one enemy is not really fun, right? We need more enemies placed in the stage. But does this mean we need to repeat the same process of placing and adjusting every single enemy? Of course not. At this point, we'll introduce the concept of the prefab. A prefab is a reusable asset that can be easily placed in the stage. We can save the Hilicho we just placed as a prefab, and every time we place this prefab, it will have the same settings. After exiting Test Play and switching to the Assets bar again, we can select the Hilicho we just placed and right-click it to find the Save as Prefab option, naming it Abyss Hilicho. Then you can see the Custom tab in the Assets bar shows the prefab we just created. Now we can place another 2 Hilichos like before, but this time we can just place the prefab instead of adjusting the level every time. However, suppose we decide that this would be too hard and we want to adjust their level to 80. Don't worry, because prefabs can share the same setting even after being placed. First, select one of the Hilichos placed by the prefab and adjust its level to 80 inches the Details panel. Then, right-click the Hilicho and select Overwrite and Save Prefab. The editor would prompt you that all references will be modified as well. After confirming, all the Hilichos placed by this prefab would be updated to level 80. Finally, we can start another test play to see the effects. Now we have 3 level 80 Hilichos in the stage, and they are much harder to defeat. In this section, we have learned the concept of the prefab and how to save and update it. Prefabs are very useful for quickly placing multiple enemies with the same settings, and also for making quick adjustments to all of them at once. We're entering an important section now. We will start implementing programming logic with the node graph system. So, how can the player win the game? Obviously when they defeat all enemies, right? So we need to count the number of defeated enemies and trigger victory when the number reaches 3. First, we need to briefly explain the concept of an entity. An entity is any object that can be placed in the stage, including enemies, gadgets, players, and the characters they bring in. Every entity has its own life cycle, and the entity is often the minimal unit of most features. However, there is a special entity called the stage entity, which is an abstract entity that represents the stage itself. It doesn't have a physical form during runtime, but it is the first entity to be created, and it exists during the whole life cycle of the stage. Therefore, the stage entity is a perfect carrier for handling universal logic. So we decide to count the number on the stage entity. The stage entity needs a special process to find. Open the system menu, click Stage Settings, then scroll to find Stage Entity and click View. We can notice that it has far fewer options than other entities. Switch to the second tab, Components, and we can see that there's already a custom variable component. Click Advanced Editing to open the variable editor, and we'll see an empty list. The control below is used to add new variables. The first box is for the number of variables to create. We can leave it as 1. The second select box is for the variable type. We can select integer to count defeated enemies. Then press Add New Variables to create the variable. After that, a variable with a default name will appear in the list. We can name this variable Defeated Count for better identification. The box next to it is for the default value. We can leave it as 0. Now we have defined a variable to count the number of defeated enemies, but it won't change by itself. From this point, we will start creating a node graph with the Miliastra sandbox. Whenever you open any save in Miliastra Wonderland, the Miliastra sandbox will automatically launch soon after, and it is the dedicated tool for creating node graphs. Focus out of the game and find the Miliastra sandbox window, and we can see it placed at the tab Server Node Graph, then Entity Node Graph. Just double-click the folder Uncategorized tab, and right-click the blank area to find Create New Node Graph. Name it Count Defeated Enemies, and then double-click it to open. At this place, you can scroll your mouse wheel to zoom in and out, and hold the right mouse button to navigate around. At any time, you can press the Save button on the bar at the bottom to save the graph. Only by doing this can you commit the changes and see the effect in the game. We will notice that there is nothing in the graph at this time. Node graphs here are triggered by an event node, where certain events the game supports are sent to the entity, and we can create logic to react to these events. To know that an enemy is defeated, we should use the event when entity is destroyed, which is triggered when an entity reaches the end of its life cycle. So we can right-click the blank area, search for Destroy, and find it under the entity-related event nodes. We can see there's one rectangular icon on the first line of the node, followed by many circular icons with descriptions. These are what we call pins. The rectangular one is called the logic pin, which is used to connect with other nodes to trigger them. The circular ones are parameter pins that specify information related to this event. There's something special about this event. This event is triggered only on the stage entity, even though it isn't the one that was destroyed. That's a natural design, because the destroyed entity no longer exists, and it can't receive any event. Therefore, this event is forwarded to the stage entity, and we must handle it there. At this time, we will do the following things. First, judge whether the destroyed entity is a creation. Then, if so, increase the defeated count variable by 1. Move the mouse to the logic pin, drag it out to somewhere, and release it. The node library that shows up will prompt filter execution node, which indicates that only execution nodes are showing up now, because the logic pin can only connect with execution nodes. For a judgment, search for double or if, and select double branch under flow control node. We notice that this node has pins on both the left and right sides. The left ones are called input pins, which receive arguments and start execution. The right ones are output pins, which provide parameters and continue the logic flow. This applies to all nodes in the node graph system. To judge whether the destroyed entity is a creation, we can use the parameter pin entity type of the event. Drag it out and choose the operation node enumeration equal, and the enumeration 1 pin will be automatically connected. Click the drop-down of enumeration 2 and select entity type creation. This node will produce a result of Boolean type, which is needed by the double branch node. So we can drag the result pin and connect it to the condition pin of the double branch node. Then the judgment is complete. We need to continue the logic on the output pin. Yes, drag it out and find the set custom variable node. Then we need to fill out the parameters. First, the target entity, or the entity whose variable we want to set. In this case, it should be the stage entity, so we can just search for the query node get self entity. Second, the variable name, which is defeated count, the one we just created. Third, the variable value. This doesn't have a box to fill in initially. We need to click the gear icon and specify that the data type is defined as integer. This type must be consistent with the type we defined on the stage entity, but the node graph doesn't automatically know that, so we need to set it manually. After that, a box will appear for us to fill in the value. And fourth, the trigger event, which we can just leave as the default, yes. So how can we increase the variable by 1? Obviously, this is achieved by calculating using the current value of it. Drag out from getSelfEntity and select the query node getCustomVariable. Just like before, we need to specify the variable type as integer at the output pin variable value and fill in the variable name as defeated count. Then we can get its current value to calculate the new value. Drag out from the variable value pin and search for the operation node addition. The first input pin is already connected, and we just need to fill the second input pin with the value 1. The output pin result will be the new value after increasing by 1, which can be connected to the variable value pin of the set custom variable node. After that, how can we react to this change? One way is to use the event when custom variable changes, which is triggered when a variable changes, and the operator specifies it to trigger the event. Just drag down to another place and right-click the blank area to create it. There's an important thing to do before using it. You must click the gear icon and specify the variable type as integer, or this will even block test play because it's incorrectly configured. We may want to react to the change of defeated count only. Therefore, we can drag the variable value pin of this event and connect it to the operation node equal and fill the second pin with defeated count. This will limit the following logic to trigger only when the variable is named defeated count and typed as integer. Then we can create another double branch by checking its post change value. Drag it out from the event node and find greater than or equal to, fill 3 inches the second pin, and connect its result to the double branch node. Now the yes output pin of this node means that the player has defeated 3 enemies, which is the victory condition we want. Drag it out and find the settle stage node, which has no parameters to be filled in. Save the graph and you're all set. However, the graph we just created won't work immediately. The node graph itself isn't created with an initial owner, so we need to let the editor know that this graph is for the stage entity. To do that, we need to go back to the game, find the stage entity again, and open its third tab, Node Graph. Click Add Exist Node Graph, select Count Defeated Enemies, the one we just created, and this graph will take effect from now on. Now we can start another test play to see the effect. After defeating 3 healer churls, the stage is settled and shows complete. In this section, we have implemented the first logic of our stage, counting the number of defeated enemies and triggering victory when the number reaches 3. We have also learned how to create node graphs and how to use event nodes, query nodes, operation nodes, and flow control nodes to create logic. Finally, we have learned how to mount the node graph to the stage entity to make it work. Now the logic works internally, but the player cannot see their progress. Users do want feedback through the display, and that's why we need the UI control groups. UI control groups are a collection of UI controls which can be shown on the screen during gameplay. By creating and configuring UI controls, we can show various information to the player and even allow players to interact with the interface to trigger some logic. In this section, we will create a simple counter to show how many enemies have been defeated. To modify UI control groups, we need to open the system menu and click Manage UI Control Groups. We will see a default layout and all controls, including default ones like the minimap and the joystick. To show something on the screen, we need to create a control. Click Add UI Control at the bottom left and select Text Box in prefabricated templates. We will configure the following properties. First, drag it to the left side and adjust it to a proper size. Second, navigate to text box settings below and set the background color to 111111 with 15% opacity to make it a bit visible but not too obtrusive. Third, write the text content as defeated, : Fourth, click the insert variable button and select stage, then defeated count. You can see the text content has an extra part, the defeated count placeholder, which is the variable we just inserted. This means the value of defeated count will be automatically shown here and updated whenever it changes. And fifth, change the font size to 24 to make it more visible. Then we can start another test play to see the effect. Now we can see the counter at the left side showing how many enemies we have defeated. After that, we notice that the real spiral abyss shows how many enemies there are in total as well. To stay consistent, we also need a variable on the stage entity to specify the total number of enemies and show it on the interface. Open the stage entity again and add another integer variable named total count with a default value of 3. This value will be initialized with that value and will stay unchanged during the stage. Then we need to insert this variable into the text content as well. Go back to the UI control group, click the text box we just created and add a suffix of a /. Then we can click insert variable again, select stage, then total count, and it will appear at the end. Now the text content becomes defeated, defeated count, / total count. As we have this configuration value for the total enemy count, we can actually use it in the node graph, instead of hard-coding the value 3. This will make the logic more flexible and easier to adjust in the future. Open the count defeated enemies node graph, navigate to where you put the when custom variable changes event, and find the greater than or equal to node. The second pin is currently filled with the value 3, which is the total enemy count we just defined. Just drag it out and find the get custom variable node. We notice that this time we don't need to specify the variable type because the parameter pin it is connected to needs an integer and the node graph can automatically infer it from the connection. Then drag out the parameter pin target entity to create a get self entity node and fill the variable name with total count. Now we can start the test play one more time and we can see the total enemy count is shown with no other difference in the logic. This is a better design because if we want to adjust the total enemy count in the future, we can just change the variable on the stage entity without needing to modify the node graph. In this section, we have learned how to create UI controls and show variable values in a text box. We have also learned how to use the same variable in both the UI control group and the node graph, which makes our design more consistent and flexible. Currently, when the player wins, the stage just ends immediately with the default settlement interface. By introducing another custom interface layout, we can place different controls on it to show a custom victory screen and then exit after a 5-second delay. Open Manage UI Control Group again, and click the plus button next to Interface Layout in the top left corner to create a new layout. We can notice that, compared to the previous default layout, there's a new layout called Custom Layout created. We want a shade like the original Spiral Abyss, so we can add a text box control and configure it like this. First, set its size to 5000 by 3000. This is a special size that will make it cover the whole screen, regardless of the resolution. Second, fill the background color with 000000 at 50% opacity to make it a semi-transparent black shade. Third, set the text content to UWin and set both horizontal and vertical alignment to center. The text will then appear in the middle. And fourth, set the font size to 128 to make it more eye-catching. Then we can add another text box, prompting that the stage will exit in 5 seconds. We can set both its horizontal and vertical alignment to center and adjust its size. However, we notice that this text box has its text shown in gray. This is because this control is behind a previous full screen shade. In the Interface Layout Editor, the priority of controls is determined by their order in the control list. The later a control is, the lower priority it has. Therefore, we can right-click the second text box in the control list and select Move Up to place it above the shade, and then its text will be shown properly. Now we have the victory layout, but it won't show automatically when the player wins. We need to change the settlement logic in the node graph to show this layout first, and then exit after a 5-second delay. First, navigate to the previous settle stage node and delete it. Instead, we will create a switch current interface layout node to switch to the victory layout we just created. At this point, we notice that this node requires a target player parameter because the UI control group is something that takes effect on the player scope. But the node graph we're creating is on the stage entity, which is not a player. We need to get it specifically. Click the blank area and search for the query node get list of player entities on the field. This will give us a list of players joining the stage. This is not an entity, but a list, because there may be more than one player entering the stage. Disconnect the double branch from switch current layout and drag out from the event node to find the list iteration loop node. This node will execute the following logic for every element in the list. The iteration list and iteration value pins also need a type. However, we can directly drag the player entity list to the iteration list pin, and the node graph can automatically infer the type as entity. Then we can connect the loop body pin to the switch current layout node and connect the iteration value pin to the target player pin of it. Now this change will apply to every player in the stage, which is important for the multiplayer experience. For the layout index value, just click the search icon in the box, select custom layout, and the corresponding identifier value will be filled in. Now the victory layout will show when the player wins, but it won't exit after 5 seconds. To achieve that, we should introduce the timer. The timer is an abstract thing that only exists in the node graph without any pre-configuration required. It does a simple thing. It triggers an event after a certain time, and this can run periodically if you specify it to do so. Now we can drag out from the loop complete pin of the list iteration loop node and find the start timer node. Fill in the parameters like this. First, the target entity is still the stage entity itself. This is the entity that will receive the event when the timer is triggered. Second, fill the timer name as delayed exit. This is the unique identifier of this timer, which is used to distinguish it from other timers when receiving the event. Third, set loop to no, because we don't need it to trigger periodically. And fourth, drag out from the timer sequence pin and find the operation node assembly list, then fill the first value with 5. The timer sequence appears as a list because the timer can actually trigger multiple times with different time intervals if you set it to loop. For example, if we add another value, 8, then the timer would trigger one more time, 3 seconds after the first trigger. After that, we can drag to another place to create the third event node in this node graph, when timer is triggered. This time we can use another flow control node, multiple branches. It is used for multiple equal condition judgments, which is exactly what we need, because we may have multiple timers. Drag the timer name parameter to the control expression, and a logic pin-like icon with a plus sign will appear. When you click it, a new output pin will be created, and it will prompt you to enter an input string. We're filling in delayed exit here, which means the logic connected to this pin will only be triggered when the timer named delayed exit is triggered. Then we can connect this pin to the settle stage node, which will end the stage and show the settlement interface. Now we can start test play one more time. After defeating all enemies, the victory layout will show, with the text you win, and the prompt for the delayed exit. After 5 seconds, the stage will exit and show the settlement interface. In this section, we have created a custom victory interface layout and changed the node graph to switch to this layout when the player wins. We have also introduced the timer to trigger a delayed exit after showing the victory layout. Our next goal is to turn one encounter into multiple waves. We know that in some floors of the Spiral Abyss, the enemies won't appear all at once, but in multiple waves. To achieve this, we need to introduce the prefab group, and a new mechanism to judge the defeat of each wave and trigger the next one. The prefab group is a collection of prefabs. Its major use is to record a set of prefabs with their relative placement, so we can pre-configure their arrangement during edit time, and just place the whole group when needed. First, let us delete the 3 helichals we placed before, and go to the third tab, Prefab Library. This is where we can manage all prefabs and prefab groups. Switch to the second page, Creation Prefabs on the left, and we can notice that even though we have deleted all Abyss helichal references in the stage, the prefab still exists here. The prefab library is a white scene with nothing in it. It's just like a draft place, and nothing here gets into the actual playing scene until we reference it in the scene. We can place one Abyss helichal prefab here as normal, but when we click it again, there won't be another helichal prefab placed. Instead, the editor will prompt current prefabs created. Duplicating a prefab here isn't as simple as clicking it again. Instead, we need to right-click it, select Copy, and right-click on the blank area to select Paste. This will produce a copy of the prefab, which will have a special icon to identify it. After placing another 2 copies, we can select all of them by dragging a box to cover them, and right-click to find Create Prefab Group. We can name this group Abyss Helichal ×3. Then we can see the 3 helichals all become copies, with the center point automatically generated. Then we need to switch to the stage entity again, and add 2 new variables, current wave to count the current wave number, and next wave defeat count to trigger the next wave. What's more, we may change the default value of total count to 6, because we want 3 helichals in the first wave, and 3 helichals in the second wave. After that, we can start modifying the node graph to control the wave mechanism. This time we will use a different approach. Spawn enemies by creating a prefab group in the node graph. We can connect to another double branch that continues when the variable name is current wave. Actually, one logic pin can connect to multiple execution nodes, and they will both be executed when the event is triggered. On the yes branch of this new node, we will connect it to create prefab group and fill in the parameters. First, the prefab group index can be viewed in the game, in the prefab library. Just click the copy button after the prefab group index and paste it here. Second, give all zeros to location and rotation. This means they will be created at the center point of the stage scene. This will match the center point of the prefab group we created, which is also at the middle of the 3 helichals, so their arrangement will be the same as we place in the prefab library. Third, we can leave the owner entity as nobody. And fourth, we're satisfied with the setting of level 80, so we can just leave override level as no. The level pin also doesn't need to be filled in under this situation. Then we need to set the checkpoint variable, next wave defeat count. This can be increased based on how many enemies are spawned this wave, so we can drag out from the output pin created entity list to create the query node getList length. Then we can just add its value to next wave defeat count, like how we increased defeated count before. The only difference is that the other input pin of the addition node is also connected to the length of the created entity list. After that, we should implement the logic for triggering the next wave. Find the double branch that accepts a condition of greater than or equal to with total count and connect its no branch to another double branch. This means the event of defeating all enemies has a higher priority. Only if the player hasn't reached the end will the next wave logic be checked. We can save some work by copying the judgment nodes for total count and changing the variable name to next wave defeat count. Notice that the connections out of the selected nodes won't be copied at all, so we must reconnect the first input pin of the greater than or equal to node to the post-change value pin of the event node. If this condition is met, we can increase the current wave variable by 1 to trigger the next wave. Things seem to be going fine, but there's one remaining problem. The first wave isn't spawned at the beginning. This time we need to introduce another event when entity is created. Thankfully, the logic under this event is very simple. Set current wave to 1, and the rest of the logic will be automatically handled by the custom variable change event we created before. Now we can start test play again. The first wave of 3 helichals will be spawned at the beginning, and after defeating them, another wave of 3 helichals will appear. After defeating all 6 helichals, the victory layout will show, and the stage will end after 5 seconds. In this section, we have learned how to use a prefab group to spawn multiple enemies at once, and how to implement initialization and checkpoint mechanisms by controlling variables in the node graph. Now this stage is something like a single-room Spiral Abyss remake, but it still lacks the time limit and star rating mechanism. In this section, we will introduce a countdown global timer and trigger defeat when the time runs out. Then we will create a star rating system based on the time left when the player wins, and show the star rating on both the victory layout and the settlement interface. The global timer is actually something totally different from the timer. The global timer is something dedicated to counting time with countdown and stopwatch modes. It is also a required feature of the timer control in the UI control group. Unlike the timer in the node graph, the global timer requires setup at edit time. First, we need to find timer management in the system menu, often the second one in the list. By clicking new timer, a countdown timer is created automatically with a duration of 5 seconds. Here we set this to 90 seconds as the maximum time to complete this stage. Then, by double-clicking the default name, Global Timer 1, we can rename it to Abyss Countdown Timer. Moreover, the global timer can't be added at runtime. Instead, we need to add it to the target entity beforehand. In this case, we can add it to the stage entity. Open the stage entity, click Add Common Component in the second tab, and find Global Timer. Then we also need to use Advanced Editing and click Specify Timer at the bottom to include Abyss Countdown Timer for this entity. This global timer will start automatically when the stage starts. After that, we need to show the user how much time they have. Switch to Manage UI Control Group and add a timer control in prefabricated templates. Drag it to the top middle area and fill in the parameters like this. First, set the type to countdown, because the global timer we've just created is also a countdown timer. Second, a warning time setting will show up, which is the time left at which the timer will show a warning to the user. We can set it to 15 seconds. Third, confirm that the source entity is the stage entity, because this is where the global timer is added. And fourth, click the red Specify Timer text to select Abyss Countdown Timer as the timer to show. Now let's start test play to see the effect. The countdown timer is shown at the top middle, counting down from 90 seconds. However, the player can just ignore the timer, because we currently added no logic to react to it. We need to trigger defeat when the time runs out. You may have noticed that every time we settle the stage, the ending screen shows not victory, but complete. This is because the settlement result is still to be continued by default. We need to set it to victory or defeat in the node graph to show the correct settlement result. First, let's find the settle stage node after the handling logic for the timer delayed exit. Disconnect it and insert a list iteration loop to give all players on the field a status of victory. Only after the loop is complete can we settle the stage, because the stage will immediately end after that. Then, we can create the fifth event node in this node graph. When global timer is triggered, we need to judge whether the global timer is named Abyss Countdown Timer, and if so, copy the settlement logic, but with the player's status changed to failed. However, a corner case arises here. If the player completes the stage in the final 5 seconds, the stage may fail before the ending screen delay finishes. For this case, we can find the start timer node for delayed exit, and use the pause global timer node to stop Abyss Countdown Timer when the player wins, to prevent it from triggering the defeat logic afterwards. After that, we can start 2 rounds of test play. In the first test, we can kill all enemies like before, and make sure we see victory in the settlement interface. In the second test, we can just wait until the time runs out without defeating all enemies, and then we can see the stage automatically exit with a failed status. Now we can implement the star rating mechanism. In this stage, we will give 3 stars if the player completes with more than 60 seconds left, 2 for 40 seconds, 1 for 20 seconds, and 0 for less than 20 seconds. We should show the current star rating on the default layout, and also show the final star rating on the victory layout. First, we need to add a variable, current star, on the stage entity to record the current star rating with a default value of 3. Then, we need to go back to the UI control group, focus on the text box control, and add new lines to show the star rating and the rules. The content is \n repeat current star insert variable stage current star /3. Then 3 lines, each starting with \n, remaining challenge time longer than 60 seconds, remaining challenge time longer than 40 seconds, and remaining challenge time longer than 20 seconds. Here we use \n to make a new line, because you can't just press enter to make a new line here. After that, the text content will be shown in multiple lines, and the current star rating will be shown as well. And then, we need to specify how many stars they obtain in the victory layout. Select the former text box, and add a line before the current prompt. You got current stars \n. Then the star rating will also be shown in the victory layout. Then, we need to implement the logic to update the star rating based on the time left when the player wins. To achieve this, we need to start a timer when the stage starts, with a timer sequence of multiple elements. After the when entity is created event, we can create a start timer node. The target entity is still the stage entity, and the timer name can be star rating timer. Set loop to no, but we'll set the timer sequence to 30, 50, and 70. This means the timer will trigger 30 seconds after the stage starts, then trigger twice more, 20 seconds after each previous trigger. Then drag down to see the when timer is triggered event. Because we use a multiple branches node here, we just need to add one more branch and fill in star rating timer. In this branch, we can simply decrease the current star variable by 1 using the operation node subtraction. There's a similar problem here. The star rating may decrease after the player wins, if they complete the stage during some time window that would trigger the timer. To prevent this, we can also stop this timer with a stop timer node when the player wins. Now we can start test play again. The star rating will decrease by 1 at 30 seconds, 50 seconds, and 70 seconds respectively. If we defeat enemies within 30 to 50 seconds, we will get 2 stars. In this section, we have introduced the global timer to create a countdown timer for the stage, distinguish defeat from victory when the time runs out, and introduce the timer usage with multiple elements in the timer sequence. This is the final and easiest part of this tutorial, so be relaxed. We're coming to the end of this journey. You may have seen other people's stages showing extra information on the ending screen, the one that is outside the stage, but still related to the stage performance. What's more, this value can also be persisted and viewed in the player's play history for this stage. This is easy to achieve using the node Set Player Settlement Scoreboard Data Display. We can find the settlement loop connecting to Set Player Settlement Success Status and create this node after it. Here is a brief explanation of the parameters. First, Set Entity is just a representation of the player entity. Here we just need to connect the iteration value pin to it. Second, Data Order is a one-based integer that specifies the order in which data is shown. The smaller this value is, the more to the left it will be shown on the settlement interface. Third, data name is the name shown on the settlement interface. And fourth, data value can be an integer, a floating point number, or a string. We want to show 2 values here: how many stars the player gets, and how much time they have left when they win. For the first node, its name will be star rating, and the value is just the current star variable we have on the stage entity. Then duplicate it, set the data order to 2, change the name to time elapsed in seconds, and change the value type to floating point numbers. Then we can calculate the time elapsed by getting the remaining time of the countdown timer. Drag out from Get Self Entity to create Get Current Global Timer Time, which will return the remaining time of a countdown global timer. Therefore, we should manually subtract it from 90 seconds to get the time elapsed. Now we can start the final test play. After defeating all enemies, the settlement interface will show the star rating and time elapsed in the top right corner, as expected. Also, if you publish this stage and play it in a real environment, you can check the play history of this stage to see the star rating and time elapsed of each playthrough. In this section, we have learned how to use the Set Player Settlement Scoreboard Data Display node to show extra information on the settlement interface and how to read the remaining time of a global timer by using the Get Current Global Timer Time node. Congratulations on reaching the end of this tutorial. In this journey, we have created a simple but complete stage with multiple waves of enemies, a complete gameplay process, a countdown timer, and a star rating system. We have also learned how to use various features of Miliastra Wonderland, including stage entity configuration, prefab and prefab group usage, node graph logic, UI control group design, global timer setup, and settlement judgment during runtime. This is just a simple example of what you can do with Miliastra Wonderland. With your creativity and imagination, you can create much more complex and interesting stages with unique mechanics, custom interfaces, and engaging gameplay. We hope this tutorial can be a good starting point for your journey in stage creation, and we can't wait to see what amazing stages you will create in the future.